As we mentioned in the previous module of this course, we can have CloudWatch Logs agents installed on your EC2 fleet and have all logs in one place. This is a further step regarding application maturity, because if you run into problems that you want to debug, instead of manually having to connect on the instances to see what's going on, you can just go to the AWS Management Console and see the CloudWatch Logs log streams. Unified logs are a very elegant and safe solution for troubleshooting, analytics, and insights about what's going on with your servers. Having a centralized logging solution helps you with security because you don't need to open administrative ports on your servers anymore, and helps with troubleshooting and insights because you can aggregate logs and see how your application is behaving in the big picture. In addition to CloudWatch Logs, another approach to centralizing logs is to use Amazon Elasticsearch and Kibana to gain insight from the data in your logs by creating dashboards. Both of these products are available in the AWS free tier. Please make sure you review the pricing information. Amazon Elasticsearch is a NoSQL database that makes it easy to search and analyze your data. It is an AWS managed service, so creating and operating the cluster is very easy and convenient. And it also comes with Kibana installed and configured by default, so everything you put into the Elasticsearch domain can be visualized by Kibana. It makes lots of sense to have your logs in Elasticsearch because it is a full-text search database engine. Let's say you stream your web server's access logs into Elasticsearch. Probably inside these log lines, you have a pattern that repeats for every access in your website. Most web servers by default already log data like requester IP address, the browser agent, the requested HTTP verb, if it was a get, put, post, delete, the return code, was it a 404 not found or a 200 OK? Once that information is in the Elasticsearch domain, you can use Kibana dashboards to visualize the number of log lines that match a specific query over time, such as HTTP return code just after a deployment. For example, if there's a spike in 404 not found, then probably files were missing in that deployment. As you saw earlier in this course, it is a good idea to have CloudWatch Logs agents installed and configured on the instances during their provisioning phase. So whenever they are created as part of your CD pipeline, they already have the agents installed and configured out of the box. There are multiple ways to stream the logs from your servers to Amazon Elasticsearch. And since we already may have CloudWatch Logs agents installed in your instances, we can use the native CloudWatch Logs integration. With a click of a button in the AWS console, you can enable the integration between CloudWatch Logs and Amazon Elasticsearch. And that's all you need to have your logs ready to be visualized in Kibana. Let me show you how you can do this. This is what we have so far, an EC2 instance with the CloudWatch Logs agent installed and configuring, sending logs to CloudWatch Logs. In CloudWatch Logs, we have a log stream that will collect the logs from that instance because we are using the agent to send the data. You can enable a service integration between CloudWatch Logs and Amazon Elasticsearch. And that's what we are going to see in this demo. Also, we are going to see how to create Kibana dashboards and see the statistics that we have from our web servers. Once we are going to send our logs to Amazon Elasticsearch, we are going to need an Elasticsearch cluster. This is pretty easy to create, and you can go through the console steps and create a new domain and follow through the steps. I already have a cluster called application logs. If you click in the cluster, you can see the Kibana URL. I'm going to copy that for now. Whenever we have our cluster created and active, we can go to CloudWatch, select CloudWatch Logs, and these should be the log groups that we have if we have the CloudWatch Logs agents properly configured on the instances. If we click here in one of our log groups, we are going to see what are the log streams that we have. In my case, I have the same application running on 5 different instances, and these 5 instances are behind a load balancer. If you click in one of them, you can actually see the information that CloudWatch Logs sends to the service. And this is a typical web server log line. It contains the remote IP address of whoever is requesting that. This is just a delimiter. Here, it inputs the remote user that is logged. In this case, I have any because our application doesn't require authentication. Then the timestamp, the HTTP verb, and the request that was made, the response code, the number of bytes that was sent, and some other information such as the HTTP user agent and the HTTPX forwarded for, which in this case is any. If we want to stream logs from CloudWatch logs to Elasticsearch, we will have to teach Elasticsearch on how to parse these log lines accordingly. To do that, we go back to the log groups, we select the log group that we want to stream to Elasticsearch, we click in Options, and we select the option Stream to Amazon Elasticsearch Service. When we do that, we just select the Elasticsearch cluster that we want to use, we hit Next, and here in the log format, we choose Other. In this window, you're going to see a sample of the logs that you have on the instance. And here is the space that we put our parser. I have already done it for convenience, and if we paste it, we can click in Test Pattern and check our parser against the sample information. We are going to see that CloudWatch logs will match 50 out of 50 events in the sample log, and if you click in Show Test Results, you will see that it is properly parsing the content. This is because Elasticsearch requires a JSON to index the documents. And basically what CloudWatch logs will do right now is transform this line into a JSON to be able to index in the Elasticsearch domain. We hit Next, Next again, and start streaming. And that's it. Now the logs from this CloudWatch logs log stream is being sent to Amazon Elasticsearch. If we go back to Amazon Elasticsearch, this is the kibana URL that I have already copied before. I'm going to copy it again, and I'm going to open a browser window and paste that URL. This is the main page of the Kibana dashboard. It displays you every single information that was received so far. From here, we can start creating visualizations and dashboards. A visualization is a filter among all of this content, and a dashboard is a collection of visualizations. The first thing that you should keep in mind when operating a Kibana console is here on the upper right corner the time period that you want the data to be displayed. I can display data from the last 1 hour. I can display data from the last 4 hours. So most of the times, if you don't see any data, check if you are watching the correct time period. Clicking here on the sidebar Visualize, I have already created 3 visualizations. The first one is requests per instance, the second one is status codes and top IP addresses. If we click in one of these visualizations, we can create a graphic, which could be a pie chart, a line graphic, a bar graphic, and many other visualizations that Kibana supports. In this case, we are plotting in this graphic the amount of requests on the instances over time. We can see that we actually have a spike here. If we want to create our custom visualization, we just go back to the visualization and click in the symbol plus. Here we can select the area, heat map, and this kind of basic charts. If we just want to display the data, we can choose data. Elasticsearch also allows you integrating with maps and time series. The status codes visualization is a visualization that shows me the status codes of the requests that are in my logs. I am only filtering by 200 OK or 404 not found. And remember that this information that we see here on the dashboard is from the last 4 hours. So always keep in mind this time range. If we select here the last 30 minutes, we can see that the behavior of the graphic change. The dashboards are aggregations of visualizations. So once I have my 3 visualizations, status codes, top IP addresses, and requests per instance, I can do a dashboard with these 3. If I request data from the last hour, we see some interesting behavior here. We see the number of requests per instance is going down because I was executing a test on these instances, simulating real connections. If we select here the last 4 hours, we can see that the number of 404 requests here during this time period is increased. And perhaps this is because a deployment with a missing file occurred. If we select, we can see actually the number of 404 requests that we have during this time and the number of 200 OKs that we had during this time. Now it's your turn to do this. Let's do the exercise.